What if I told you that invisible plastic is hiding in your drinking water? These particles are so small, most filtration systems can't catch them, and they are everywhere, our oceans, rivers, and even the water we drink. But what if there was a way to eliminate these tiny threats? The answer might just be here. Nanoplastics, tiny plastic particles smaller than 100 nanometers, are an emerging environmental concern, particularly in water bodies like oceans, rivers, and lakes. These minuscule fragments result from the degradation of larger plastic items or are intentionally produced for specific applications. For example, they are used as a component in personal care products, they are used as coatings, and they also find applications in bioimaging. These particles can accumulate in marine bodies, disrupting biological functions and entering the food chain, ultimately affecting human consumers. A study shows that ocean is polluted by 8.3 million plastics per cubic meter of water. Impact on human health due to plastic contamination of food and beverages remain largely unknown because there are no standardized way to determine or quantify the amount of nanoplastics in the food sample. We can assume that plastic particles can cause physical injury by damaging the intestine when consumed with food, which is caused by the simple fact that plastics rub against tissue. They also have the ability to bind to all kinds of compounds when they come into contact with fluids, thus acting as their carriers. They can carry harmful chemicals such as heavy metals or persistent organic pollutants and microorganisms. Once ingested, these chemicals can leach into other living beings, which may lead to long-term health impacts. Microscopic techniques are used for determining the presence of such particles, but they give incomplete results. Microscopic analysis along with spectroscopy is somewhat an efficient way to determine their presence. Recent studies show that there is a presence of microplastics in all salt and sugar samples. The size of these microplastics range from 0.1 mm to 5 mm. 5 grams of nanoplastic per week are said to be entering our body. By some estimates, roughly 240,000 nanoplastic particles exist in each liter of bottled water. Quite alarming, isn't it? Conventional water filtration methods like carbon filters and reverse osmosis are great for removing large particles, but when it comes to nanoplastics, these systems aren't effective. The particles are just too tiny. Scientists at the University of Missouri have developed a groundbreaking technique to remove nanoplastics from water. Using natural liquid ingredients that have low toxicity, the team has shown that they can remove around 98% of nanoscopic polystyrene beads from fresh and salt water. The solvent that researchers have engineered is non-toxic, hydrophobic eutectic solvent which floats on the surface of water like oil. When mixed with the liquid and allowed to reseparate, the solvent picks up microscopic plastics in the water and carries them to the surface. Sucking up the top layer of liquid with a pipette, the team at the University of Missouri found that they could remove nearly all nanoplastic beads from their contaminated water samples. In salt water, the method worked at extracting 99.8% of all polystyrene pollutants. Only a small amount of solvent is needed for a large volume of water. According to the researchers from Mizzou, it is a cost-effective and potentially sustainable solution to the nanoplastics problem. They will be exploring methods to recycle the solvents, enabling their reuse multiple times if necessary. With further research, the technique could even prove useful for cleaning water of other pollutants like forever chemicals. According to a study published in Environmental Science and Technology Letters, researchers have found that boiling tap water can remove up to 90% of nano and microplastics. When hard water is boiled, calcium carbonate crystals form and encapsulate the nano and microplastics. This chalk-like residue, also known as line scale, can be removed by pouring the water through a coffee filter or stainless steel filter. The effectiveness of this method depends on the hardness of water. In samples with 300 mg of calcium carbonate per liter, nearly 90% of nano and microplastics were removed, while in softer water samples with less than 60 mg of calcium carbonate, only about 25% of nano and microplastics were removed. Fight against plastic pollution is far from over, but innovations like the one from the University of Missouri bring us one step closer to a future with cleaner, safer water for all. If you like this video, you can also watch my video on how protein is produced from carbon dioxide. Don't forget to hit the subscribe button and stay tuned to my channel for more updates on the latest breakthroughs in food technology and for the latest trends in food science. Thanks for watching. Bye.